Okay, so in this video we're going to be talking more about 3.2, which has to do with the periodic table. Before we continue our notes for 3.2 today, I want you to try to answer this do now question on your own using your notes from 3.2 that you took last class. Okay, and so the question says, which of the following are not true statements regarding elements in group 1 from the periodic table? Okay, and the answer choices are A, these are alkali metals, B, these elements are highly reactive in water, C, examples of these elements include oxygen, neon, and carbon, or D, examples of these elements include sodium and potassium. Okay, so try to answer that question now using your notes from 3.2. Okay, and hopefully you answered the question correctly. The correct answer is C. Okay, Um, so group 1 are alkali metals. They are highly reactive in water. In fact, last class, you should have seen some videos demonstrating that fact. And group 1 is in the very far left-hand column of the periodic table, and group 1 does include sodium and lithium and potassium and cesium and rubidium. Just to name a few examples, oxygen, neon, and carbon all appear elsewhere on the periodic table besides group 1. Okay, so hopefully you answered that question correctly using your notes. Okay, so moving on, just a few things before we continue in this video. Please make sure that you're filling in your 3.2 notes as we go through everything. Make sure that you're labeling your periodic table as we go through everything in the notes. And just one more thing about the Edpuzzle videos that you're watching. After I grade your Edpuzzle videos, you will be able to see the feedback I leave for you within the video. And so sometimes in the Edpuzzle videos, I'll ask you like, do you have any questions about something? And that is your opportunity to ask questions if you don't understand something, and then I can answer those questions, and you'll be able to see my answers to your questions after I finish grading the Edpuzzle video. And so once I do that, if you just go back into Canvas and you click back on the assignment and scroll down, I think there might be something you have to click, but you should be able to click through and see what answers I have to your questions. So please take a look at that feedback. I will try to leave that feedback for you during the class time if possible. Please make sure that you finish your Edpuzzle videos by the end of the class period. Make sure that you're using your time in class wisely. There's no reason you should not be able to finish the Edpuzzle video by the end of the class period since you have 90 minutes for the class. And so please use your time wisely, otherwise there will be consequences for that. And of course, one of the benefits of having videos is that you can always go back and rewatch parts of the video if you need to in order to better understand the material. And so please take advantage of that opportunity. Okay, so we're moving on in the notes today. In the last class, we talked about metals, nonmetals, and metalloids, the different parts of the periodic table, and we colored those in on our periodic tables. And so today we're going to kind of go more in depth as far as the different aspects of the periodic table. And so just to kind of remind you about what atoms are, because the periodic table is basically just a way of saying all the different elements or all the different atoms that exist in the universe. So just to kind of refresh your memory about what is in an atom, there's basically two main parts to an atom. Okay, in the middle of the atom, or in the center of the atom, you have what's called the nucleus, which we've talked about before. And the nucleus contains two types of particles. The nucleus contains protons, which have a positive charge, and neutrons, which contain no charge. And if you add those two numbers together, you get the mass number. We've talked about that before. Okay, and so the nucleus exists at the center of the atom. Now, the nucleus is important in different ways, but for what we're going to be talking about in the rest of this unit, it's not really going to affect anything chemically. Chemical reactions have more to do with electrons, and the reason for that is just because the electrons in an atom are on the outside of the atom. Okay, and so inside the nucleus, or inside the atom, you have the nucleus at the very center of the atom, and then the rest of the atom is mostly empty space. Okay, on the very outside of the atom, you have electrons. Okay, and so you can see in this diagram right here, you have the nucleus in the center, you have kind of empty space, and then on the outside, these blue negative signs, those are the electrons. And the electrons are located in specific locations called shells. In this diagram right here, you can see the shells, they look like rings. And we're going to be talking a lot about shells, so it's important that you can kind of like visualize this in your mind, what this looks like. But these shells are where the electrons exist, and each shell can only hold a certain number of electrons. Okay, and so the ones we're really going to focus on is shells 1 and 2, um, or 1, 2, and 3, I guess. But the first shell can hold up to 2 electrons, and then shell 2 and 3 can hold 8 electrons. And so, for example, in the bottom left here, we can see two shells here. The first shell has 2 electrons, 1, 2, and then the outer shell has 1, 2, 3, 4, 5. I think one of them kind of got cut off in the video, but there's actually 5 electrons. You might only be able to see 4 on the outside there. Okay, and so the second shell can hold up to 8 electrons, but because this is nitrogen, and nitrogen doesn't have 8 electrons, that's why you only see 4 or 5 electrons in the outer shell there. Okay, and so each shell can only hold a certain number of electrons, and what we're really going to focus on in this video and the next video is the electrons in the outer shell, the outside shell, and those electrons are going to be called valence electrons. Okay, so I'm going to go to the next slide. Okay, and so here is just a visualization. This is not in your notes, but this is just a picture to help you understand what valence electrons are. So here in this diagram, you can actually see 3 different shells, 3 different rings where the electrons live. And remember, in the first shell, you can only have 1, 2 electrons. And then in the second and third shell, you can have up to 8 electrons. So here you can see shell number 2 has 1, 2, 3, 4, 5, 6, 7, 8 electrons, and so shell number 2 is full. And so what if you have more electrons than that, then you go to the next shell. Okay, and so here you can see, I'll draw a box around them. You actually have 2 electrons in shell number 3, and because this is the outer shell, okay, this is the outside shell, we call these valence electrons. Okay, and so when we talk about the valence electrons of an atom, we're only talking about the electrons on the very outside of that atom. Okay, so you could have an atom that has like 40 electrons, but it might only have 2 electrons. That means 2 electrons in the outside shell of that atom. Okay, and the reason we only care about valence electrons and we don't care about all the electrons is because the valence electrons, because they're on the outside, they're the most likely to be able to interact in reactions like chemical reactions and stuff. Okay, so that's why we're going to be focusing on valence electrons. Okay, and so you don't have this picture again in your notes, but if you want to draw it, if you want to pause it here and add that to your notes, you might find that helpful so that you know that the valence electrons are the electrons on the outside shell of an atom. Okay, so going to the next slide. Now, in the last video, we talked about how in group 1, group 1 are the alkali metals, and so group 1 includes things like lithium, sodium, and potassium, and we talked about how all the alkali metals in group 1 actually react in similar ways. And so even though they're not the same element, they have similar types of reactions, especially when you put them into water. And there is actually a reason for that. And you can see that reason here in this picture. And again, this picture unfortunately is not in your notes, but if you wanted to draw it into your notes, if you want to pause here and do that, that might be a good picture to have. But if you take a look at this picture, you can kind of start to see a pattern between lithium, sodium, and potassium. Lithium has 3 electrons. Okay, and the reason lithium has 3 electrons is because it has an atomic number of 3. And so if you have a neutral atom that has an atomic number of 3, that means you're going to have 3 electrons. And so lithium has 3 electrons. Notice that 2 electrons fill up the first shell, and then the third electron goes in the second shell because the first shell can only hold 2 electrons. And so lithium has one valence electron. It has 3 electrons overall, but has one valence electron, meaning one electron on the outer shell. Sodium is a much bigger atom. Sodium, if you count the electrons, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 electrons. And so that's a lot more electrons. But if you look how many electrons there are on the outer shell, we still only have one valence electron. And again, valence electron meaning electron on the outside shell. Okay, and hopefully you start to see the pattern, but potassium is the same. If you actually count how many electrons potassium has, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, and so potassium actually has 19 electrons, but it also only has one valence electrons. Again, the valence electrons are only the ones on the outer shell. Okay, and notice that the first shell can hold 2, the second shell can hold 8, the third shell can hold 8, just like we talked about before. Okay, and so what you notice here is that all of the group 1 elements have the same number of valence electrons, and valence electrons are the ones that matter when you're talking about chemical reactions. Okay, and so that's why lithium, sodium, and potassium, when you put them into water, they all react in a similar way. Right, so pause it there if you need to look at that some more. Okay, and so we've talked about the alkali metals in group 1. All of the alkali metals, aside from having these properties, low density, low melting point, good electrical conductivity, very chemically reactive, all of the alkali metals in group 1 have one valence electron. And we actually just saw a demonstration of that on the last slide. Okay, in group 2, it's kind of hard to see the bottom one because it got cut off a little bit. But group 2, all of the atoms in group 2 have 2 valence electrons. Okay, and so make sure that you're adding this to your notes if there's a space for this, but group 2 has 2 valence electrons. If you want to label this on your periodic table to make this easier to remember, that might be a good thing to do. So group 1 elements, 1 valence electron, group 2 elements, 2 valence electrons. Okay, pause it here if you need to write that down. Okay, this is just what I was talking about before about how the group 1 elements all have 1 valence electrons and that the valence electrons are responsible for chemical reactions. So there's not really anything new on this slide that I have not already talked about. Okay, group 3 is in the same group as aluminum. Okay, group 3 has 3 valence electrons. Group 4 has 4 valence electrons, and so basically as you're going like across the periodic table, you start with 1 valence electron as you go along the periodic table, and you basically go up by 1 for each column. And so group 3 has 3 valence electrons, group 4 has 4 valence electrons, group 5 has 5 valence electrons, and group 6 has 6 valence electrons. So what I mean, for example, is oxygen has 6 valence electrons. Sulfur, which is atomic number 16, has 6 valence electrons. And so all the atoms in that column, in that group, have the same number of valence electrons. And so this is all stuff that you should be writing down on your periodic table so that you can just look at your periodic table and immediately know how many valence electrons an atom has. Okay, and then group 7 and group 8, have 7 and 8 valence electrons. Now, remember what I said before about group 8 are called the noble gases, and noble gases are not reactive at all. And the reason for that is that noble gases, remember, each of those outer shells, besides the first shell, each of those outer shells can hold only 8 electrons. And so that means the noble gases have 8 valence electrons. Their outer shell is filled. Okay, they don't have any openings. They're not missing anything. And because of that, we'll see that is why they are not very reactive, because they already have all the electrons where they want to go. All like the shell, the outside shell is completely filled up. And so those elements are happy with the number of electrons they have. And so that's why they're very unreactive. Okay, so pause it there and make sure you have that in your notes. And the very last thing we're going to talk about this video is how to draw what's called Lewis dot structures, or Lewis structures. And basically, this is just a diagram that shows the valence electrons for an element. Okay, does not show the total number of electrons. It only shows the valence electrons. And so that's why it's important that you understand the difference between valence electrons, which are only the electrons in the outside shell, versus the total number of electrons. Okay, and also has nothing to do with protons or neutrons or anything else like that. In the next part of this unit, we'll talk more about bonding and chemical bonds and how the valence electrons are involved in bonding. Okay, but first let me show you some examples of Lewis dot structures. Okay, and so what you see right here are examples of Lewis dot structures. We have the chemical symbol, and then we have a dot to represent the number of valence electrons. So just to give you an example, if I go to my periodic table, if I look at K, K is the symbol for potassium. Okay, potassium is in group number 1. And group number 1, I know, because I wrote this down in my notes, that group number 1, all of these elements have 1 valence electron. And so potassium has 1 valence electron, and so you can see in the notes that I have 1 dot to represent that potassium has 1 valence electron. Carbon, you can see right here in this Lewis dot structure, has 4 valence electrons. And so if I look back at my periodic table and I see, group 1 has 1, group 2 has 2, and then going over to here, okay, this group right here has 3, and then 4, and then 5, 6, 7, and 8 is the last group. Okay, and so carbon has 4 valence electrons, and so that's why in your notes you see the 4 dots next to the C representing the 4 valence electrons of carbon. Okay, and so what we're going to do now is we're going to learn about the rules for drawing these Lewis structures, and then I'm going to show you how they're supposed to look. If you just pause it here, I'm going to maximize the screen again. If you go ahead and make sure all of the blanks in your notes are filled in, this slide right here has the rules for drawing Lewis dot structures. So you might want to put like a box or star next to the slide in your notes so that you remember that this is an important slide in your notes. Okay, so make sure you look at all the rules that are written down here. Okay, so rule number 1, you start by drawing the element symbol. For example, here they wrote Cl. Number 2, you figure out how many valence electrons there are based off of the group number. And so because chlorine is in group 17, it has 7 valence electrons. That means I should have 7 different dots around the chlorine, which I don't have here, but this is not a complete Lewis dot structure. And then you start drawing dots starting on the right side of the symbol. You draw a dot, and then you go clockwise and you put 1 dot on each side of the symbol until all of the dots are used up. Okay, and some elements are going to have 2 dots, but you cannot have more than 2 dots on any one side of the symbol. So you can't have like 3 dots on one side. Okay, you can't have more than 2. Okay, so it should start off with 1 on each side, and then if you need to go more than 4, then you can start having pairs of dots. Okay, so let me just show you some examples of Lewis dot structures. Okay, so here is boron. Okay, and so I'm going to look at my periodic table, and I'm going to see that boron is right here, and boron has, let's see, this is 1, 2, this is going to be 3 valence electrons, and then it's going to be 4, 5, 6, 7, 8. The last row is always 8, and so if you have trouble remembering, if you just remember that the last one is 8, you can also count backwards from there. So 8, 7, 6, 5, 4, 3. So boron should have 3 valence electrons. Okay, so that means when I go to draw the Lewis structure for that, I know there's 3 electrons. Okay, sorry, 3 valence electrons. And so I'm going to start with 1 dot here, and then I'm going to go clockwise, and I'm going to do 1 dot, and I'm going to do 1 dot. Okay, and so that is going to be it for my boron Lewis dot structure. So pause there and make sure that's added into your notes. Okay, so let's just do a few more examples. Okay, this example is for magnesium. So I would look at my periodic table. I would find magnesium, which is right here. Okay, and I see that it's in group number 2, so this is going to be 2 valence electrons. Okay, so it's 2 valence electrons. And so I'm going to start with 1 dot here, and then 1 dot here, and that's going to be it. Okay, that's it for my Lewis dot structure. Pause it there, add that to your notes. And then we will just do a few more examples. What I want you to do is I want you to try to do this one on your own. Okay, so pause it here, try to do this one on your own. Okay, so oxygen. I see oxygen. Let's see, this last group has 8, 7, 6 valence electrons. So oxygen should have 6 valence electrons. Okay, so I'm going to go back. I know oxygen has 6 valence electrons. And so I'm going to do 1, 2, 3, 4, 5, 6. Okay, and that's what it should be for oxygen. So pause there, make sure you add that to your notes. Check that versus the one that you did. Okay, phosphorus. So pause it here, try to do phosphorus on your own. Okay, so the P, so I'm looking on the periodic table, P is right here. So this group 8 is going to be 8, and then 7, and then 6, and then 5. Okay, so this group right here has 5 valence electrons. Okay, and so I know there's 5 valence electrons, and so I'm going to do 1 dot, 2, 3, 4, 5. Okay, so that's what the Lewis dot structure should look like for phosphorus. Okay, I'm going to go to the next one. Okay, so again, pause it here and try to do this one on your own. So I look for fluorine on my periodic table. I see it's in group 17, so it has 7 valence electrons. Okay, so 7 valence electrons. So 7 total, so I'm going to have 1, 2, 3, 4, 5, 6, 7. Okay, and so that's what the Lewis dot structure should look like for fluorine. Pause it there if you need to add that to your notes. Okay, and then the last one, this is bromine. Again, I look at my periodic table, Br bromine, so it's right here. It's actually in the same group, group 17, so that's going to have 7 valence electrons. Okay, so I'm going to have 7 valence electrons, so 1, 2, 3, 4, 5, 6, 7. Okay, so that would be the Lewis dot structure for bromine. Okay, and then we're just going to do one more example and then we'll basically be done with the notes. So I want you to try to answer this question on your own. This question says the elements in group 7 are called the halogens. Which of the following best explains why halogens all share similar reactive properties? Okay, so try to answer that question on your own. Okay, so the answer is C. They all have the same number of valence electrons. All of the halogens have 7 valence electrons. That's why they all behave in similar ways when it comes to chemical reactions. Okay, because they have the same number of valence electrons. So the correct answer should be C there. Okay, so this should be the last slide in your notes. And this is basically just a fact about helium, that when you're talking about helium, helium is the only atom that has 2 valence electrons. Because remember, the first shell only holds 2 electrons, and so this is what the Lewis dot structure looks like for helium. Okay, so you should be done with your notes now for 3.2. Hopefully you understand after watching this video what valence electrons are, how different atoms have different chemical reactivity types because they have the same number of valence electrons. Remember, valence electrons are the electrons in the outer shell of the atom, and hopefully you understand how to draw and interpret Lewis dot structures, which involve valence electrons for an atom. Okay, so as always, please let me know if you have any questions, and I will see you guys in the next video.